Hi future doctors, welcome to the next class. In this class, we will see what is surface tension offered by the liquid. Okay, wherever you are feeling this surface tension means if you are taking on a table 2-3 drops of water or liquid. So on that, if you place one glass, so whenever you are pulling this glass like this, then you will feel some amount of force. That is when this is the glass. Just if you are pulling this upwards, you will feel that you are applying some amount of force. This is going to be pulling downwards. Same thing will happen on water surface if you are taking any object, mug or bottle, empty bottle if you place on surface of the water. So this water is going to pull this object downwards. So you will be pulling away, then this liquid will pull downwards. You will feel this one also because of surface tension. Next, if this is the liquid surface, if we are immersing a painting brush means like this it will be. Whenever you are immersing, this hair of the painting brush will become like this. Whenever you are immersing downwards. Whenever you are pulling it away, it will be going like this. So why it will be coming like this? Why it is going to be like this means some amount of force is going to act in this direction. Whenever you are pulling inside, whenever you are pushing outside, same force is going to act like this. Now this force is tangential to the surface, parallel to the surface. Tangential means parallel to the surface and perpendicular to the imaginary line. This is the imaginary line, isn't it? Hair of the brush, we are going to call it as imaginary line. So if this is the liquid surface, if you are viewing from top of the vessel or water bottle, so this is the imaginary line means force is going to act like this. On this imaginary length, surface tension T is going to be defined as force per unit length. Force is equal to surface tension into length of the device. Now, in this we are applying force in upward direction. If you are taking weight of this object negligible, liquid, then we are going to take surface tension into length. Okay, so length of this glass, bottom of the glass length we have to take, that is only 2 pi r if it is circular. That one we will see. This is one of the definition and equation for surface tension. Units Newton per meter, dimension formula ml t power minus 2 by L, that is going to be mt power minus 2. Still if you want to understand how surface tension is going to be coming, where it is going to be coming means, if you are taking one ring in soap solution, if you immerse one layer, soap layer is going to form like this. Soap layer is going to form like this. So if you blow air, soap bubble will be coming like this. That is coming because of surface tension. This layer is forming because of surface tension. Whenever you are applying soap for your face, then if you are after rubbing between the fingers, if you do like this, between the fingers soap layer is going to form. That is also because of surface tension. If you place one small thread which is used to stitch our buttons, so like this, if you tie, if you tag and gently if you place like this, it will be coming like this. Then by taking small needle, if you pierce, if you made small hole here, it is going to acquire spherical shape like this, it will be coming. So why it is going to come like this? On this imaginary length, force is going to be perpendicular and it is going to be tangential to the surface, perpendicular to the imaginary length. So force is going to act like this. How much force is acting on this length? We are calling it as surface tension. This came because of circular shape. This one came because of circular shape, because of that surface tension force. This is the equation, surface tension into length. Another one, simply I am saying this layer which is having liquid layer. So on the top of this, so which one is having sphere of influence we are going to call sphere of influence. Any molecule which is going to attract another molecules up to certain region, the space or region up to where this attractive force is going to be coming. So this is called sphere of influence. Within this, each and every molecule will be at cohesive force. Cohesive force means the force of attraction between two same molecules. Same molecules means water molecule. Same molecules, cohesive force. So vessel is made up of some material, glass or iron, copper, steel. So between steel molecule and water molecule, we will be having adhesive force. So at angle of contact, again we will define cohesive force and adhesive force. So this layer if you cut, so it will be coming like spherical shape, like this it will be coming. That is because of surface tension. So all these molecules within the surface will be having potential energy per unit surface area. This one also we are calling it as surface tension. Potential energy is equal to surface tension into surface area. Now to form this liquid drop, how much work we did means surface tension into surface area. These two formulas are important for surface tension definition. One is force per unit length, another one is potential energy per unit surface area. So all molecules which are at near the surface of the liquid, which are under sphere of influence, isn't it? So those molecules will be having potential energy per unit surface area. We are calling it as surface tension. So these two equations are main for us now. One is this work done, another one is this force. From this, how you will get different forces, we will see. Find the amount of force required to pull the needle from the surface of the liquid, they will ask. Whenever they are taking needle, liquid is in touch with this side and this side. Therefore, length they will take. Force is equal to surface tension into length they will take L plus L. That is going to be T into 2L. The amount of force, minimum force required to pull the needle. So, but in this we are taking, whenever we are taking this needle on the surface of the liquid, we are taking that weight of the liquid displaced is negligible. Otherwise, you have to write here plus weight of that liquid displaced also. But this one we are neglecting, only force we are going to be writing. Because of needle, you cannot get more weight weight of the liquid displaced can be neglected because needle is very small weight you will be having. So whenever you are taking needle here, this is the needle you can assume. So I am pulling with two fingers like this. Liquid also will hold like this. Therefore, if you want to pull this one upwards, you have to apply about this length and this length. Therefore, you will take 2L. You cannot pull by taking like this. So liquid will hold like this. Therefore, we will write 2L, you should not forget for the length. If you are taking ring, just ring if you are taking, again liquid is in touch with inside and outside. At the time, the minimum force required to pull the ring from the surface of the liquid means 2 pi r plus 2 pi r. So 4 pi rt. Next, in place of ring, if you are taking disc if you place on the surface of the liquid. So if you are taking, this is the disc, if you place on liquid surface, only bottom surface is in touch with liquid, not top surface. Therefore, bottom surface is having how much length means force is equal to T into only one length, that is 2 pi r. Next, square plate if you are taking, square plate of each side length, square plate like this it is there. That is also only it is get in touch with bottom surface, not top surface. Therefore, F is equal to T into length. What is the length of this one means? 4A because of bottom surface. If you are taking square loop if you are taking, at the time it is in touch with inside and outside. At the time T into 2L. T into what is length of this? 4A. So 80 they are going to write. So like this you have to see how many surfaces in touch get in touch and how much force is going to be required. So if you are taking glass which is having circular shape. So if you are keeping this glass which is having bottom circular shape on the surface of the liquid, how much force you have to apply to pull it upwards? Let us assume this is circular shape. whenever you are taking on the surface of the liquid, so only bottom surface is in touch with liquid. Therefore, if it is circular means force is going to be T into 2 pi r. So, this is about shapes they will give circular, square, rectangle. So, whichever they are giving, always you should remember surface tension definition is force into length, isn't it? Sorry, surface force definition is surface tension into length, not force into length. Correct? T into L. This T value they will give for it, surface tension of that liquid. So length you have to take depending on what they have given in the exam. Next, another one we said one liquid drop. So whenever you are taking our hand or fingers into the liquid, and if you are taking outside means from the end of these fingers, whenever liquid is coming, it is going to gain definitely spherical shape because of surface tension. Because of small volume of liquid always going to acquire lesser surface area, which is having lesser surface area means out of triangle, square, sphere, cone, among all those, sphere will be having lesser surface area. Therefore, spherical drops are means liquid drops are spherical in nature for small amount of volume, not for large amount of volume. If you pour water from water bottle, it will not gain spherical shape. It will be having particular shape. It is going outside. So spherical shape is going to be coming for only small volume. That is because of surface tension of the liquid. Now, what is the work done to form this liquid drop? They will ask. Previously, we did work done or potential energy. U is equal to surface tension into surface area. What is surface area formula? 4 pi r square. Air is in touch with only one surface. Therefore, we will take 4 pi r square surface tension. So, what is the work done to form soap bubble? They will ask. What is the work done to form soap bubble means? So inside and outside what will be there means air will be there. It is in touch with two surfaces. Therefore, work done is T into 2 times of 4 pi r square. Same like this here. It is in touch with two lengths, 2L. It is in touch with only one length. Only one length will take. So air is in touch with one surface. Then 4 pi r square, only one surface area. Air is in touch with two surfaces. That is going to be 8 pi r square t. This is to form soap bubble. How much work we have to do? This is work done to form liquid drop 4 pi r square t. Here r is radius of that liquid drop, radius of that soap bubble. How this soap bubble will be coming means already we said one ring we will immerse in soap solution. If you blow air here, so one soap bubbles will be forming. So to form that soap bubble, this much work you did 8 pi r square t. So from here, so we will continue in our next class. How much force you will feel this force whenever you are pulling object upwards. You should pull slowly. You should not pull suddenly. Then you will feel this force. Or liquid is filling means liquid is applying force in downward direction. Okay. So you will feel this surface tension. So whenever liquid is at rest position. So mosquitoes, spiders can stand on the liquid surface which is at rest position because of this surface tension property. So that is the work done to form soap bubble and liquid drop. So remaining we will see in our next class. Thank you.